Today, we're diving into one of the foundational concepts in computer science, the von Neumann architecture. Whether you're a computer science student, a tech enthusiast, or just curious about how computers work, this video is for you. So, let's get started. The von Neumann architecture, also known as the Princeton architecture, was first proposed by the mathematician and physicist John von Neumann in 1945. It's the fundamental design for most modern computers and is based on the concept of a stored program computer, where both data and instructions are stored in the same memory. Here's a simplified diagram of the von Neumann architecture. Let's break it down into its main components. First, we have the central processing unit, or CPU. The CPU is the brain of the computer and is divided into two main parts, the arithmetic logic unit, ALU, and the control unit, CU. The ALU performs all arithmetic and logical operations, like addition, subtraction, and logical comparisons. The control unit, on the other hand, directs the operation of the processor. It tells the ALU what operation to perform and manages the flow of data within the system. Next, we have the memory. In the von Neumann architecture, both instructions and data are stored in the same memory space. This is a key feature because it allows for more flexible and efficient use of memory, but it also means that the system can be vulnerable to certain types of errors and exploits, such as those caused by trying to execute data as if it were code. Finally, we have the input, output, I/O components. These are the interfaces through which the computer communicates with the outside world. This includes devices like keyboards, mice, monitors, and storage drives. Now that we've covered the main components, let's talk about how they work together. In a von Neumann machine, the process starts with the control unit fetching an instruction from memory. This instruction is then decoded to determine what action is required. If the instruction involves arithmetic or logic operations, the control unit will direct the ALU to perform the necessary calculations. The result may be stored back in memory or sent to an I/O device. This cycle of fetching, decoding, and executing instructions happens billions of times per second in modern computers. It's what allows them to perform complex tasks so quickly and efficiently. One thing to note about the von Neumann architecture is what's known as the von Neumann bottleneck. This refers to the limitation caused by the single shared bus for both instructions and data. Since the CPU can either read an instruction or write data at one time, this can create a bottleneck that slows down the processing speed. Let's quickly summarize the advantages and disadvantages of the von Neumann architecture. On the plus side, the von Neumann architecture is simple and flexible. It's easier to design and build compared to other architectures, and it's well suited for general-purpose computing. However, the main disadvantage is the bottleneck issue we mentioned earlier. Additionally, because both data and instructions share the same memory space, there's a risk of errors and security vulnerabilities. In conclusion, the von Neumann architecture has been a cornerstone of computer design for decades. While it has its limitations, its simplicity and flexibility have made it the foundation for the majority of modern computers. Thanks for watching. If you found this video helpful, be sure to give it a thumbs up and subscribe to our channel for more tech insights. If you have any questions or topics you'd like us to cover, leave a comment below. Until next time, keep exploring the fascinating world of technology.